Hi everyone. Today I'm going to talk about performance and optimizing your regular expressions. So regular expressions tend to backtrack, and so that's what I'm going to be talking about here and how to optimize that. Essentially, a regular expression will, by default, it'll parse from left to right, against your string, and and in certain situations it might have to backtrack, go from left to right, and then go back a bit, try it again, and repeat that over and over. And you should try to minimize that because it's going to kill your performance. And in some cases, if you have a really poorly written regular expression, like I do here, then you'll get you can freeze your application, and bad things will happen there. So this example I'm using now it actually comes from a popular article on the web you could search for. It's called Catastrophic Backtracking, and so this is a good one because it doesn't take much to make this really, really slow. Um, so let's try. If you put a bunch of X's in here, and keep on adding a few X's, you'll start seeing this progress circle show up as it's processing. So at this point, it's pretty slow. It's taking, a few seconds to evaluate that. If you put a Y at the end, it evaluates a whole lot faster. It terminates the regular expression sooner, prevents a lot of that backtracking. But this is what we need to optimize for, because this is abysmal. This is terrible performance right here. And so what I'm going to do is fire up the benchmarking tool. And this is really good to use. I highly recommend that you at least test any regular expression that's going into production code. You test it at least once in the benchmarking tool just to make sure that it's not really slow. You don't want something in your production code that's going to affect, like in the example of a website, you don't want to affect your scalability. So what we've got here is way too slow. All right, let's go back just a few. Okay, run that again. Okay, that's a reasonable. That's a reasonable length of time to start with. Okay, so we'll start here and just make it faster. When you look in this regular expression, you can see a number of problems with it, but so this whole x plus thing is pointless, because that's telling it to match an x one or more times, and then an x one or more times, and that's kind of redundant to do that. And so I'm going to change this to x plus. It's going to accomplish exactly the same thing. It essentially is going to require two x's, and then it's going to allow more than that as well. So it accomplishes the same thing as before, but as you could see, it's a whole lot faster. So that's over 6,000% faster. We're up to 45 iterations per second now. Now, so another detail I want to cover, though, is the parentheses here. That's actually a capturing group. So it's going to try to capture that into a group, which you can then use like in a replace, for example. So in an example when something actually matches, then you can see it's actually putting the match into group 1. But if you're not actually using the captured group for anything, then there's no point in using it. There's no point in writing it this way. I mean, so what you can actually do is change it back. Okay, change this to a non-capturing group, which is just denoted by $:. So that still gives you kind of the nice features of a group, because you can put like a quantifier at the end of it and repeat it if you need to, but it's not capturing the value into a group. So it's actually a little bit more efficient. So we're up 72% just by doing that. However, in this particular case, there's another option we have, and that's the non-backtracking sub-expression. And so that is done just like this. And you know, you can see all of these things if you're writing the Regex expression from scratch. You would have seen it right down here. There's the non-backtracking sub-expression. So that's how you do that. And in our particular case, this is going to give us the same functionality. We're going to get the same effect. You know, if you put a y at the end, it still matches the y, so that's all good. But we run it, and it's ridiculously it's much more efficient. It's the other bars down here are invisible now because it's so much faster. 105,000% faster. Okay, so keep on going. So this plus is technically useless because you don't need to repeat XX plus over and over and over. It doesn't do you any good. So we'll get rid of that too. Run that. It's faster still. And just make sure, yeah, it still matches when the Y is on there. Another last trick, in this particular example, since we have this Y at the end, we can actually do right to left and run that, and it's faster still. So all of this, pretty much all of this has been about reducing backtracking and forcing the Regex expression to terminate early when no matches are found. And this, you know, I've covered several techniques that I often use whenever I run into a performance problem on Regex expression. And yeah, hopefully this has been helpful for you. And you guys definitely should use this benchmarking feature because it's very enlightening to uncover these problems and before they make it into your production code. So thanks for watching.